So now we're going to look at tree diagrams with replacement. So the question we're looking at in particular is a situation where we're in a neighborhood and people can own one of three different types of pet. Now, of those people, two-thirds have dogs. What do we got? 1/6 have cats. I guess that means 1/6 has birds. And the question asks, if you choose two owners at random, what are my chances? Of getting a cat owner and a bird owner. So cat and a bird. That's probably a little thing to keep an eye out for to start with, because sometimes we can be asked a cat or a bird owner, which would change our question a little bit. So we're going to use tree diagrams to solve this. So what we want to think about is, say you pick your first person. Well, you're going to have three different things that can happen. You've got a 2 out of 3 chance of getting a dog. Oops, that's not quite how we do it. You've got a 1/6 chance of getting a cat. And you've got a 1/6 chance of a bird. So this is what's happened. You pick one person out randomly. All right, next thing that happens is that you then pick another person. And what's happening here is once I've picked a person, it's not like they've disappeared from my people who I can pick. I could pick the same person twice and get the same dog owner twice. So it's not going to change our odds here. The next time that we do it, we're going to have exactly the same odds again. So once again, 2/3 dog, 1/6 cat, 1/6 bird. I'll cheat a little bit here. Alright, so now I've drawn my tree diagram. So these are the two things that happen. First thing, I either get a dog, a cat, a bird. Next person I draw out, I get another dog, cat, or a bird. And we're interested in the chances of getting a cat and a bird owner together. So what we have to do is work out what branch of our probabilities or our tree have we gone down. So to get a cat and a bird, I can't go down the dog path, can I? Because then I can only get a cat or a bird. So that whole path there, if I was to go up this way, is completely out. But I can go down this way and go cat, bird. And I can go down this way and go bird, then cat. Right? So now we have to work out what the probabilities of each of these trees happening is. And to work that out, so if I've gone down a certain tree, then I look at the probabilities that I've gone past on my way to the end here. So I've had a 1/6 chance of getting a cat and then a 1/6 chance of getting a bird. That means for this little tree here, my probability of that happening is 1/6. We just times our fractions together. 1/6 times the top and the bottom, which gets me to 1/36. So I've got a 1 in 36 chance of this happening, of getting a cat owner and then picking a bird owner. Looking down to our next one as well, we can see that to work out what's happened here, I've got a 1 in 6 chance times 1 in 6 again, which is going to equal 1/36. So the two different ways that I can get to the end here is 1 in 6 chance of going this way, 1 in 6 chance of going that way. Just for example, if I wanted to work out the probability of getting a dog owner and another dog owner, I'd go down that way. Then I would do 2/3 times 2/3. 2/3 equals 4/9. That would be my probability of getting a dog and a dog. So 4 out of 9 times that I that I did this selection, I would end up with a dog owner. So we'll just get that back out of the way. Cool. So now we've worked out that we've got this 1 in a 36 chance and a 1 in 36 chance going this way. And because I've got two probabilities, two paths that I've gone down, I just need to add my probabilities together now. So to work out total probability, I go 1 over 36 plus 1 over 36. When I add two fractions with the same denominator, and that's probably, sometimes we can simplify this part over here, but if you leave them all unsimplified, then you're always going to be adding up. It's going to help you when you add up your fractions because you're not going to have to find common denominators again. So that's going to equal 2 over 36, which equals 1 over 18. That's my probability of getting a cat or a bird owner in the situation where I pick two people out of a group, and those are the odds of getting it.